children, welcome to Zero Panic Maths. Now let's move to the next problem. Okay, here also we are going to find out the LCM and HCF of the following integers by applying the prime factorization method. But one thing that you should observe here, whether all these numbers are composite numbers first, whether to represent it as a product of prime numbers, whether the given numbers are composite numbers, that we need to verify first. 17 is not a composite number, it is a prime number. 23 is a prime number, 29 is also prime number. So we can write it as, since we need not factorize this, okay, since 17, 23 and 29 are all primes. So when there is a set of primes given and you are asked to find out the HCF is always 1 because there is no common factor involved in all those numbers. Okay, so HCF of 17, 23 and 29 is 1 only. Okay, now what about LCM? Now since all these are prime numbers, they will not be having any common factor altogether. So LCM will be always the multiplication of all the given numbers. Okay, if there is no common factor, you have to multiply all the numbers to get the LCM. Okay, so LCM of 17, 23 and 29 is actually the multiplication of 17, 23 and 29. What is the value of this? It is 11,339, and this is the LCM of 17, 23 and 29. Okay, now let's move to the next problem. The numbers given here are 8, 9 and 25. Let us write the prime factors of that. 8 is actually 2 to the power of 3, is it not? 2 into 2 into 2, it is 2 to the power of 3. 9 is actually written as 3 multiplied by 3, which is 3 to the power of 2. 25 is written as 5 and 5, which is 5 to the power of 2. If you observe, in all these prime factors representation, there is no common factor between 8, 9 and 25. So what will be the HCF? If there is no common factor, then HCF of 8, 9 and 25, 8, 9 and 25 is 1. Now why I am saying 1? Because there is no common factor. Okay, HCF requires the common factors with lowest powers. So if there is no common factor, there is no HCF. It means HCF is commonly 1. LCM of 8, 9 and 25 is actually multiplication of all the factors with highest powers. It is 8 multiplied by 9, it is actually the numbers only, 25. Okay, will come up to 72 multiplied by 25. 25 7 times, it is 175, that is 1750, it is 1800. Okay, so that is the LCM of 8, 9 and 25, since they don't have any common factors inside it. Okay, Now let us move to the next problem. Okay, the fourth set of problems in exercise 1.1 is given the HCF, we need to find out the LCM. Okay, what is given here is HCF of 306 and 657 is 9, and we need to find out the LCM of the same. And we know what is that? We know this formula, HCF of AB multiplied by LCM of the same two numbers is equal to the multiplication of the two given numbers, where A is 306 and B is 657 for us. Okay, now since multiplication of LCM HCF is equal to the product of the two given numbers, and we need to find out the LCM. HCF is already given, and what is the value of that HCF is 9. Okay, so we're going to write it as 9 multiplied by LCM, okay, is equal to the product of A and B. What is A and B? 306 multiplied by 657 are the given two numbers. So LCM is equal to, take this 9 to that side, it will become the denominator 9. Okay, 9 ones are 9 threes are 27, 3 remains, 9 fours are 6, 36. Okay, so that is 34 multiplied by 657. What it will sum up to? It will sum up to 22,338. And this is the LCM of the two given numbers 306 and 657. Okay, now let us move to the next problem. Okay, this is a little bit of different kind of problem. We need to find out whether the number 6 to the power of n can end with digit 0 for any given natural number n. If you remember, the similar kind of problem we have already discussed in the last session. The same method of finding out the solution for this we're going to follow here also. Okay, now let us start with the solution. So assume that 6 to the power of n ends with 0. Okay, now since 6 to the power of n ends with 0, it should be divisible by 5. You remember that any number that ends with 0, say you take any number 10, 20, 30, 40 and so on, 100,000, any number you take, that number also has a factor 5. It means that that number is divisible by 5. Okay, so with that knowledge only, we will say that since 6 to the power of n ends with 0, we say that 6 to the power of n is divisible by 5. Okay, so what is the meaning of 6 to the power of n is divisible by 5? 6 to the power of n has the factor 5. Okay, so 6 to the, therefore it means that 6 to the power of n, okay, has one of the factor 5 and call it as equation 1. Okay, what is the meaning of this? 6 to the power of n will be such number which is divisible by 5 and it has the factor 5. Okay, now let us continue with the representation of 6 to the power of n. Okay, how can I write 6 to the power of n? 6 to the power of n but 6 to the power of n can be written as 2 multiplied by 3. So I'm just writing the prime factorization of 6 to the power of n. And again, by the rule of powers, a multiplied by b to the power of n will be always a to the power of n multiplied by b to the power of n. So I can say 2 to the power of n and 3 to the power of n. So what does it says? The equation, okay, let us call it as equation 2. Okay, equation 2 says that 6 to the power of n has the prime factorization only in terms of 2 and 3 and no other prime factors in the representation of 6 to the power of n is involved, because you can say 6 to the power of n here is n times 2 multiplied by n times 3 and no other factors involved in the prime factorization of 6 to the power of n. That is what equation 2 says. Okay. Okay, so we will see that only. So from equation 2, we arrived at we arrived that 6 to the power of n has only two factors, that are 2 and 3. Okay, there is no other factor. But what equation 1 says, 6 to the power of 1 has one of the factor as 5 also. So since we have achieved this, the equation 1 is assumed to be false. Okay, so therefore equation 1 is false. Equation 1 is false. Now since equation 1 is false, how did we achieve equation 1? By assuming that 6 to the power of n is ends with 0. Okay, so since equation 1 is false, the assumption itself is false. Okay, so there, since equation 1 is false, we can say the initial, we can say the assumption itself is false. Assumption is false. Okay, therefore 6 to the power of n does not end with 0. This is the solution of this. Okay, let us move to the next problem. Before we proceed to find out the solution for these problems, we need to see what exactly is a composite number and what is the definition of the composite number. Okay, if you know the definition of the composite number properly, then you will be able to solve this problem easily. Okay, what is composite number? Composite number is a number that can be represented by the product of its primes. It means it has more than two factors. Okay, so it has a factor other than one and itself that can divide it. Okay, so we need to just prove that the two given numbers, this and this, are composite numbers by proving that it has other factors also in the representation of these numbers other than one and itself. Okay, so that is how we are going to prove this. Okay, let us start with the first number. 7 multiplied by 11 multiplied by 13 plus 13. Okay, let us find out the value of this number first. 7 multiplied by 11 multiplied by 13 plus 13. Okay, so this is one term, this is the second term. I can take 13 common, and it remains with 7 into 11 into 1, okay, plus 1, which is equal to 13 multiplied by 7 11s are 77 plus 1, which is 78. So if we find out the value of this, which is 1014, you can say that the value 1014, which is represented by this equation, okay, is represented by 13 and 78. Okay, though 78 is another composite number, we have a prime factor 13, which is actually the factor of 1014, which is in turn the factor of 7 multiplied by 11 multiplied by 13 plus 13. Okay, so therefore 1014, which is actually this equation, okay, 1014 has the factors as 13 multiplied by 78. You can say 13 and 78 are the two other factors other than 1 and itself. So any number that has the factors other than 1 and itself is a composite number. So 1014, that is 1014 is a composite number. Okay, that is actually this number 7 11 13 plus 13 is a composite number. Okay, this is how we proved that 7 11 13 plus 13 is a composite number. Hope you understood this. Okay, let us continue with the next problem in a similar fashion. If you observe this carefully, this value 7 multiplied by 6 multiplied by 5 4 3 2 1 is actually a 7 factorial. Okay, 7 factorial plus 5 is a composite number. That is what the problem given here. Okay, but let us continue with the same thing here. So we need to first find out what is 7 factorial plus 5 value. Okay, and then we need to prove that that value can be represented by some factors other than that value and 1 itself, so that we can prove that it is a composite number. Okay, so let us write that 7 multiplied by 5 multiplied by 6 multiplied by 5 multiplied by 4 3 2 and 1 plus 5. Okay, let us take 5 as common. When you take 5 as common, what remains here is 7 6 the, okay, and then 5 is common. What remains? 4 3 and 2 and plus 1 from this part. Okay, so let us have the multiplication of this and find out the value of that. Okay, 7 6 the 42 multiplied by 4 3 is 12 and 24 plus 1. Okay, 5 multiplied by, what is this, 24 multiplied by 24 2s are 48, it is, and then 24 4s are 92 and 96, 24 4s are 96 plus 4 1000, 8 plus 1. Okay, so it is actually 5 into 1009. Okay, now what is the value? Exact value, it is 5000 plus 9 5s are 45, 5045. Okay, actually 5045 is the value of this. Okay, now since 5045, which is in turn represented by this number, is represented as the product of factors, prime factors, you can say 5 into 1009. It has the factors 5 and 1009 other than 1 and itself. Therefore, the given number is a composite number. Given number is a composite number. Okay. Actually, you need to write the two more steps here, that since 5045 is a composite number, and in turn it is represented by this number, you need to finally say that the given number, this is a composite number because it has the other two factors other than 1 and itself. Okay. Now let us move to the next problem in exercise 1.1. Okay, this problem is little bit different from all the other problems that we have discussed till now, because this has given with some description, and we need to find out what is given and what we need to find out. Okay, now let us read this. There is a circular path around the sports field. Okay, Sonia takes 18 minutes. Okay, let us mark that. Okay, it is a circular path and Sonia takes 18 minutes to drive one round of the field, whereas Ravi takes 12 minutes for the same. Okay, and what is asked? Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So here in this problem, we need to first understand what exactly is asked. What is given here? Okay, to start with the solution, we need to check what is given. Given are the two data, one is 18 and another is 12. 18 minutes that Sonia takes to drive around the field and 12 minutes that Ravi takes to go around the same field. Okay, we need to find out that after how many rounds Sonia and Ravi meet together. Okay, so suppose this is the round circular path, then if they start at the same point, then for Sonia it is 18 minutes and for Ravi it is 12 minutes. Okay, so now let us generically will say two after two rounds Sonia will spend 36 minutes. Okay, whereas after three rounds Ravi will spend 36 minutes. It means that after 36 minutes, both Ravi and Sonia meet at one common point. So now why I am writing this? Because the problem here is to find out the common time after they start at the same point at the same time, after how many minutes they are going to meet together. Okay, and that common point is actually the least common multiple. Okay, least common multiple of 18 and 12. What is least common multiple? It is LCM of 18 and 12. Okay, so actually this problem is to find out the LCM. They are not directly saying that to find out the LCM of 18 and 12. Okay, so let us find out the LCM of 18 and 12. That will be the answer. And let us see whether the LCM of 18 and 12 comes up to 36 only. Okay, so 18, write the prime factors of 18. How do I write 18? 18 is 6 3s are 6. I can again write it as 2 into 3. So 2 into 3 into 3, which is 2 to the power of 1 and 3 to the power of 2. Okay, and 12. How am I writing 12? 4 to the power of, 4 multiplied by 3. And I'm going to write it as 2 into 2 into 3, which is 2 to the power of 2 and 3 to the power of 1. Both the factors are common here. Okay. Now, how do I find out the LCM? LCM of 18 and 12 is equal to all factors with highest power. You remember the LCM. All factors, that is 2 to the highest power 2 and 3 to the highest power 2. Okay, it is 4 9s are 36. You got this 36? Okay, this is the answer as I already explained to you. So therefore, the final answer is Sonia and Ravi meet after 36 minutes. So this completes all the problems in exercise 1.1. In the next session, we will be continuing with revisiting the irrational numbers. Okay, thank you.